The species recognition hypothesis does not explain the presence and evolution of exaggerated structures in non-avian dinosaurs. The hypothesis that the exaggerated structures in various non-avian dinosaurs, for example horns, crests, plates, primarily functioned in species recognition, allowing individuals of a species to recognise one another, is critically examined. Some of the evidence presented does not support the hypothesis as claimed, or is equivocal or erroneous. We conclude that species recognition was not the evolutionary mechanism most likely to be driving the appearance and persistence of exaggerated structures in non-avian dinosaurs. The term species recognition has been applied to different concepts by different authors, and there is little consistency in its use. So this is shown very clearly here that there is actually a kind of trend on a theme in these dinosaurs. So if we look at this game bird phylogeny, there is really no rhyme or reason to the evolution of these kinds of feathering and wattles. In fact, the only reason that this phylogeny is as it is because these are extant animals that have been DNA tested. There's almost nothing like a stegosaur living around that area, so having distinctive plates and spikes doesn't really speak of, a function of species recognition, because there's nothing else like it. Paleontologists who pore over these bones and use protractors and fine measurement tools to measure and describe all of these frills and bosses and things like that. Even we can't use those always to tell the difference between species. And so how would an animal just by looking tell if it's the same species or a different one? So why would you have a change in your frill, a change in your horn, a change in your size, and all of these other different things just to be recognised? So this is specifically referring to iguanodontians like Iguanodon and Mantellisaurus on the Isle of Wight. If you saw my Iguanodon video, then you know there are also multiple Iguanodontians living in the same area, and sometimes of a similar size to Iguanodon in the Iberian Peninsula, like in Spain. These large dinosaurs seem to have no problem in recognising each other and recognising whether they're the same species, whether they're a different species, and they didn't have any crests or anything like that, and they seem to get on fine. Individuals of the population might prefer one form of crest over the other, or a crest over none, but this would represent mate choice, not mate recognition. So mammals, lizards, birds, they all get it on occasionally, and sometimes more regularly, with members of a different species. They are not choosy over species. This is contra Padian and Horner, who asserted that an animal cannot consider mating with another unless it first recognises that they are conspecific. No, that is definitely not true. So this again speaks against clear, recognisable signals being used for herd coherency, because it was the small ones with little crests and horns, which are not very distinctive, being found more in herds than adults which have larger crests and horns, which seem to have been more solitary. Future analyses must first establish which, if any, factors may correlate with species recognition in extant clades before testing for them. There is currently no good evidence that might support this hypothesis, and it should not currently be considered viable. Triceratops, a common chasmosaurine ceratopsid dinosaur from the late Cretaceous of North America, is known for its cranial ornamentation, including a single nasal horn and large paired supraorbital horns. It is commonly surmised that Triceratops used its horns in intraspecific combat, but this hypothesis has not been rigorously tested. Scale models of Triceratops skulls were used to determine if it could physically lock horns, as has been suggested. 3 hypothetical horn-locking positions were found, involving various orientations of the combatants' skulls. Based on these positions, it was hypothesized that injuries caused by horns were especially likely in certain portions of the frill, jugulars and postorbital horn core tips. This corresponds to some previously reported pathologies in chasmosaurine specimens. Uncertainties in this modelling exercise centre around variations in horn orientation, size, shape, and the possible existence of a keratinous supraorbital horn core sheath. Triceratops differs from modern horned mammals in its horn orientation, which suggests if it engaged in intraspecific combat, its fighting style was quite different from these modern animals. During hypothetical horn locking in Triceratops, most of the force was directed against the medial and lateral surfaces of the horn cores. This has implications for future studies of ceratopsid cranial functional morphology, especially as related to horn core architecture and the development of the frontal sinus complex.